Hi everyone. We are up to day 4 of the YouCubed videos that you've been watching this week. I thought today was very interesting how it talks about speed not being important in math. And I know I've been guilty of looking for speed in solving math problems, trying to get the answer fast. Like she said in the video, calling on the first student to raise their hand, and I am trying to do a better job of slowing down, giving everyone time to solve the problem at their own pace. A lot of times when you take your time, you can see different ways of solving a problem, and those are some of the things that we can learn the most from, are different strategies to answer a problem. Today we're going to talk about something called a conjecture. That may be a new word to you. In science, we would usually use the word hypothesis, which you may be a little more familiar with. So basically, a conjecture is a hypothesis for math, and it is something that we believe to be true and will test, but can't prove definitively that it's always correct. Now, hopefully you just watched the video on how hailstones form, where they are constantly going up and down in those big cumulonimbus clouds, to form larger and larger hailstones. Today we're going to look at something called a hailstone sequence. So please take a look at the handout to follow. Okay, now we're going to give it a try. So in order to do this hailstone sequence, we're going to have to start with a number. What I want you to do is pick a number. It could be a large number or a small number, and we're going to follow the 2 rules that were listed in the handout. Remember, the first rule is if the number is even, divide it by 2. Then if the number is odd, multiply it by 3 and add 1 to it. Now, to give the hailstone sequence a try, remember the 2 rules that we're going to be using. So you're going to pick a number to start with. If it's an even number, you'll divide it by 2. If it's an odd number, you'll multiply by 3 and add 1. Pick your number to start. Following those rules, let's see what happens. So if you were to start with the number 10, 10 is an even number, so I'm going to divide it by 2. Now I have the number 5. And with an odd number like 5, I'm going to multiply by 3 and add 1. So that 5 now becomes 16. Now keep working with those numbers and the numbers that you're getting, following the same 2 rules to see what happens. We're going to try to make a conjecture about this hailstone sequence. We're going to take about 15 minutes, and I want you to choose several numbers to start with, following the same rules of the hailstone sequence, and see what kind of results you're getting. See if you notice any patterns or any similarities depending on what numbers you're starting with and what happens. After about 15 minutes, let's take turns sharing what we've discovered as we're working with these different numbers. Okay, so what did you discover? I'm guessing you found that no matter what number you started with, you always ended up with the number 1. Now, believe it or not, this was discovered by a mathematician in 1937. His name was Lothar Kolatz, and this is called the Kolatz conjecture. Now, mathematicians have been trying for years to disprove his conjecture. Of course, his conjecture being, if I follow those two rules that we just worked with, any number will eventually become 1. Now, that's been tried by mathematicians with enormous numbers, numbers so big that computers have had to be used in order to test this conjecture. And guess what they found? So far, it's true. There has not been a single number that has not turned into 1 by following the Collatz conjecture. Pretty fascinating, isn't it? And certainly something that would take a lot of time to do correctly. So much time that we haven't even tried all the possible numbers with this to see if it will still work. Okay, I hope you enjoyed learning about the Collatz conjecture today. This would be a great thing to talk about over dinner tonight if you wanted to test your parents' mental math skills and see what they discover by trying a number and calculating it through those two rules of the Collatz conjecture. Don't forget to check into the Canvas module for all of the other work that you need to do today. For the rest of the week, we may have a couple of things on Canvas and a few more activities to do on Khan Academy. Please make sure to get those done by the deadline so that I can have an accurate record of who's getting on and doing the work online. And don't be afraid to let me know if you have any questions. Have a great day.